Welcome everybody, and thank you for joining me in this live. We are going to focus on the scrap reduction and actually to see step by step how we are going to reduce the scraps by 50%. And what I'm going to do is I'll share you strategies, practical applications, real world examples, and that you can start using them practically right away, even if you have never worked on scrap reduction before. And what I'm going to show you is that we're going to go through the exact processes that some of my clients are using in manufacturing, where to start, what to focus on, and actually what to avoid if you want to go to reducing your scraps. And I will show you the most common mistakes I have seen in the field, so you can avoid them and basically stay on track. So if you just start with scrap with your scrap reduction strategy, it will look a little bit more like what you see on my screen. Let me make it a little bit bigger. And how it works is that if you start from zero, you can expect something similar as you see here. In the first year or the first year and a half, you may have a massive improvement if you put the effort. And we're talking about 20, 40, or even 60% of scrap reduction. And this is what happens when you take it seriously for the first time. And now this applies like if you've ever worked on scrap, if you've never worked on scrap before, or if you made big shifts, for example, in the way you do your data visualization, or if you just decide to put the extra effort to make it work. The first year and a half, you will see massive improvements. But here's what's going to happen. You will start hitting a plateau. After 1 year and a half, you may have all the massive reductions. You may be able in a year and a half to save even half a million of euros or dollars. And then you will have a plateau where all your efforts will go to maintenance of what you did or on small reductions such as 2 or 5%. And in this case, you don't really want to stop the effort. You want to keep maintaining the effort that you put, but you have to be aware of that. And what happens is now I will show you a little bit my philosophy when it comes to scrap reduction. My philosophy looks a little bit like this. Um, so overall, like if you have to think about iceberg, like the tip of the iceberg. Okay, the overall scrap percentage is probably what you present all the time. Is the tip of the iceberg, and it tells you something. It tells you where you are, respect to your targets and how much you save and how much it costs you. But on its own, it's just sharing data. What really matters is to go deeper, to see all the little details that give you the scraps. For example, which are the most problematic shifts? Um, Scrap by model, scrap by machine, scrap by component. Which is the component creating more scraps? The top 5 reason codes. Which machine parameters give you the highest scraps? Compare the line A with line B. Compare maybe the morning with the evening, or even include your quality controls there. This is what really matters. In my opinion, in my experience, what I have seen is that you if you want to any system that claims to reduce your scraps needs to give you this type of visibility. If it doesn't, it's guesswork and it's not really going to give you anything important to work with, and it cannot really guarantee you the results you're working for. But you know what? Enough with the talking. This is a little bit of a small introduction for me. And basically, I would like to show you a little bit walk you through the actual steps you need to follow in order to do this scrap tracking and to have this scrap analysis so that you can reduce your scraps. And I will show you exactly all the steps that you need to follow. But before we go there, um, I would like to ask you where you come from, which part of the work you're seeing me from, and right now I'm in Greece, but usually I live in Treviso. And let me know in the comments where you come from, if you come from Europe, from Asia, from United States, and let's keep the conversation alive. And so, if I go back, as I promised, I'm gonna show you the step-by-step strategy, and keep in the comments. Try to engage if you want, or write me where you come from. And of course, if you have any questions, let me know. And basically, if this is the first step, okay, the first step is to register your data. You need to register your data with the scraps. And the easiest way to do it, if you have never done it before, if you don't have really complicated systems, if you're a small factory, is to do it manually. The operator goes in the line with a specific form. It can be done with multiple systems. It can even be done in Excel, basically. And they register the machine that they are monitoring, the line, the quantity of the scraps, and the reason codes, maybe some comments. They click submit, the data are stored on a system. Now, this is the most simple way, but we can make it, we can evolve it from there. We can connect it to the ERP. For example, we have the ERP, we have the production of the program of the production, and basically you have the operator that clicks on the code and he registers the data. He registers the machine, the quantity of the scraps, and the reason codes and some comments, and he clicks submit. You can go ahead with this. You can also do it automatically if you have a more advanced system, but you don't really have to start there. You can do it manually, and you can do it semi manually with a ERP system. What really matters in this case, of course, is if you have a structured way to collect your information. That's the most important thing. And if automation is not an option, you can use clear forms like the ones I show you, and you can really go through this phase. Now we connect the data, and now we have our data, and we need to go to the dashboards. When you build a scrap dashboard, what you really need is to see as many sites as possible without, excuse me, you need to be able to see as many sites as possible without clicking around, right? Um, you want to make the information as open as possible for the one that consumes it. So as you can see in this example that I'm showing you right now, you may want to make it a little bit bigger. Okay, so that you can see it. As you can see, this example that I'm showing you right now, you may want to have the area. You have the scrap cost per area, just assembly A, assembly B, or gluing, and you compare it with the targets. And if the scrap is higher than the targets, it's red, and if the scrap is lower than the targets, is green, which we're going well. And in case it's red, we want to see as many details as possible. We need to be able to see the top reason codes. For example, in this case, it's wrong setup. We want to see the models that create the most scraps, which can be the model A. As you see here, model A, model B, model C, 70% of the scraps come from model A. So it means that there is a problem with the recipe of the model A or a particularity from the model A. Or you want to be able to compare the two different shifts, how much scrap the shift A did compared to shift B. Of course, you may, like every single factory is different. Okay, it's like not all production lines are equal, and not what I'm showing you right now is useful for every single factory. You can't really apply the same logic to all of them, but what I'm trying to show you is that you need to have as much details as possible so that you can really focus on your action plan, basically. And since not every single line, not all the production lines are equal, and not one factor is equal to the other one, I always push for flexibility. I don't really like to have the systems that are plug and play, that go fit for every single application, every single factory. A factory that makes fridges has a total different structure than a factory that makes paper, and a factory that makes paper has a totally different scrap structure than a factory that makes chemicals. So we really need to be able to have flexibility, and that's why I suggest always Power BI, because you can build dashboards and can give you insights, and you can go as much detailed as possible. And that's what you can see here. Of course, as I'm telling you, this is just theory. Okay, I'm trying to explain you a little bit how it looks in theory, but if you want to see real examples, if you want to see how manufacturers are actually creating their scrap reduction analysis, make sure to book a call with me, and I will run you through examples and applications and results that you can actually use them. And this can be actually, if you see how others are structuring their dashboards, it can be the first step for you to have this scrap reduction strategies. And so make sure to click the link below, have a call with me, and we can run through all these examples all these real world examples that we will discuss now. And so, okay, now we have our dashboards, we have our data, we collect our information. And what do we need to do right now? What we need to do is basically have meetings. We need to see our scraps daily, even for 15 minutes a day. We didn't need to focus on the details of the scraps. And if we have a big team, the whole team needs to see them, even with daily meetings of 15 minutes at least. And we need to do the Gamba walk, okay? When we see something a problem, we need to go in the line and we need to see the real scraps. We need to talk to the operators. We need to really understand, we need really to be able to connect the the scraps that we are doing, what we see on the screen, with the real world. And how you do it? You do it by immediately when you see the data, you go in the production line. And that's why it's important to have the data updated daily and not weekly, because if you wait for a week, the scraps are not going to be there, operators are not going to remember what they did, and so you're going to lose the information. You need to act quickly. And third part is the action plan. The action plan is that every single stakeholder needs to perform an action so that you can reduce your scraps. And that's why you really need a lot of details here, because when you have a lot of details, you know, for example, that the gluing in line A, model A, has 70% of scraps for wrong setup. That's straightforward. You need to find a way to make the setup quicker, easier, and improve the recipes. That's straightforward. Another example is that you have the gluing in line A and line B, and basically in line A it says it does, I don't know, 10% of scraps. In line B it does only 2% of scraps. In this case, you need to improve the recipes of the line A and basically focus on the maintenance of this machine, of the specific line. But in order to do the action plan, you really need as many details as possible. And sometimes the action plan is just to see the data, just to be able to connect the data of the scraps with machine parameters or with the quality controls. And And this is how it works. And basically, what you can expect, let's say that you do a lot of effort and you are really motivated to reduce your scraps. And what you're going to see is that in the beginning, the first year and a half, you may see the massive reduction of scraps. You may see 60% reduction. And this is because if you have never seen your scraps before and you start applying methodologies that work, you're gonna have a massive improvement because it's gonna be something new, and before you may not even know what you're scrapping, and out of a sudden you know exactly what you're scrapping, the reasons, and you can focus on the easiest things first. First year, 1 year and a half, you may have 20 to 60% reduction of scraps. As we go by, it will be more difficult to make improvements. We need to keep on the efforts because we need to maintain the results we obtain, but we can aim for the perfection, 2 to 5% reduction. And many times, I will show you, like I would like to show you a little bit the common mistakes that everybody does. That sometimes scrap reduction activities don't really give the results we want, and I will show you 4 reasons why. And then these are not from the encyclopedia. It's not reasons that I searched on ChatGPT. They are things that I learned from doing. And basically, they are the first mistake is that they have very little details. Okay, it's like you want to reduce your scraps, but you just know how much scraps you're doing. You just show data, or you may know a little bit further how much scrap you do per area. It's not really working. You cannot really have an action plan. Nobody can have an action plan, a real action plan, if they don't really have details, right? And so we want to avoid that. And what we want is to have to know which shift was more problematic, which model created scraps, which machine created the most scraps, the regional code of the scraps, the components. If you have assembly, compare line A to line B. You want to compare morning to the evening. You want to compare the quality controls. You really need to have as massive details as possible. You can't really you can't really have a cost reduction um, strategy by just sharing that we scrapped. I don't know, 3%. It doesn't really work. You need to see as much details as possible. The second is I see people that they usually analyze their scraps manually on Excel files, and they analyze them weekly because they don't really have the time. That's very sad because I don't really see I don't really think that they're gonna have big improvements from that. Why? If I control my scraps daily, I can go the next day when there is a big if there is a big problem in the production line. I can go in the line, okay, and see the real scraps. They will be somewhere left, there will be somewhere on the side, and I can really see the problem. And I can really see that if someone writes as a reason code aesthetic issue or sharp edges or something like this, I can really see what's this sharp edges. Okay, I can really take pictures and I can archive. Maybe I can update my reason codes because I see the real parts. And I can go to the operator that was working there and I can ask him questions. And maybe the shift A made more scraps than the shift B. Yes, I before assuming anything, I need to talk with the shift A. We need to understand him, and he will remember because it's something that happened yesterday. If I control my scraps weekly, there is nothing you can do. You don't. Probably the scraps are thrown away. Someone took them. They are in the trash probably, or you may start re-elaborating them because maybe you scrap something and you re-elaborate this material, and then when you go to the operator, they don't really remember what happened. Nobody remembers. It's just a matter of luck. So we need to if we want results, we need to be able to understand daily what's happening. I don't really mean that you have to go every single day in the line and see, but at least when there is a big spike of scraps, you really need to go there and understand quickly what happened. Okay. This is very common, okay? When you analyze your scraps in Excel files, when you do extractions from the ERP and from SAP, from whatever system, and there you have someone, a person that just does this minor preparation by himself. That's copy paste, pivot tables, calculate, filter, export, copy, and then they create, and then they do this work manually. First of all, you lose a lot of money because if this person needs 3 hours weekly, or I don't know, 1 hour daily, basically this is 180 euro per month. This is a lot of money you have to pay for the person that does that because they occupy time for them. And the other thing is that it you can't really have the data when you need them. You have a lot of mistakes, and the person, instead of doing this work of manually working with his data, he can be outside in the line these 3 hours and actually do something important. Actually do modifications, control the recipes, um, control if the shift A understands the same things that the shift B understand the quality controls. Instead, you make the person work as a machine. And I see it is so common because a lot of people work with Excel files. What you really need to do is to do it automatically. It costs much less, it's much cheaper and much more affordable, and it will save your employees a lot of time that they can use for the scrap reduction actually activities and for the action plan. And this is the other part. This comes from the management team. You receive the results, you achieve some results. Maybe you worked the first year, you achieved some results, and you had, like, I don't know, 20% reduction of scraps. And then you said, we are fine, we reached the targets. Nobody think about scraps anymore. And after a year, the same scraps appear. You go back to where you were before. You need to do some maintenance in this case. Like, you need to at least to control the scrap at least once per day to understand what's happened without putting that much effort. You need to do some maintenance of the results you achieved. The other part is the is the total opposite. Okay, it's not bad, but people expect that the first year and a half we had this massive improvements, 40% reduction, and then we want this 40% reduction to go to 80% reduction. We want to push beyond the threshold, and basically it doesn't happen. After 1 year and a half, you reach the plateau, and now with all the effort in the planet, you can aim for 5, maximum 10% of improvements. So they put a lot of effort and they ignore all the other activities, trying to squeeze as much improvements as possible. I think that in this case, it's better if you have a hybrid approach. You put a lot of effort in the beginning, you do the scrap reduction to, I don't know, the 50%. You do a lot of effort in the first year and a half, and then you do maintenance, okay? You don't really need to have massive action plans. You do some maintenance so that you can maintain the results you already achieved. And this is a great way to manage what you already did, but without losing all the effort that you took, without having a reactive approach, or without getting too greedy. So these are the 4 examples, the 4 common mistakes. I will show them again. If you want to see it, it's like you have very little detail. If you want very little detail, you will never do any scrap reduction as much effort as you put. You are doing manual analysis. That's so common. I really love the picture with Jim Carrey. Uh, they create a lot of stress, and it actually occupies a lot of resources and a lot of mental ability from the person instead of just making him do the work in the line. You have low frequency, and these two are connected. When you have manual analysis, data analysis manually, you can expect to have uh, your analysis daily. You have to go for weekly, and this makes you not be able to see the actual parts that you scrap in real time and ask questions to the operators when let's say that when the problem is hot. You go after a week and they don't even remember what happened, and you have inconsistency. You do see some results and then you stop working, or you have too much effort, you put too much effort and you burn yourself out. So these are the common mistakes to avoid. Of course, this is the most common one, and I highly recommend you to fix this one. And basically, that's it. And as I explained you, now we're gonna close the this scrap reduction live. Add any questions you have below. Let me know what you think. Let me know if you have anything you want to ask. And as I told you, this is theoretical. Okay, I'm giving you some theoretical some theoretical advices right now, and some graphs. But if you want to see some real examples that will make you understand much better how to work, how the dashboards are structured, and really start to work on this project right ahead, let me know. Book a call with me or message me on LinkedIn or Facebook, and we will get you started. We will show you real examples and applications, results from other clients, and you will able to. It will be the first step that you do to improving your process. So if you don't have any questions, I will close you now, and I wish you a very beautiful and productive day. Bye bye.